Table basics. Let's talk about how data is stored in a database. So in a database, all the data is stored in a table. And tables are sort of like spreadsheets, but just a little different. So I want to walk you through how a table is put together and how we can make it very efficient. Now let's suppose that have the task of collecting address information and courses that a student has taken. Okay, so what we'll do, let's go ahead and add some columns. Okay, we're going to collect first name, last name, street, city, state, and zip. And let's add some course information. Department, course, section, and course title. So the first thing we need to do is add a student. So we're going to add John Smith. He lives in my town, Montana. And let's have him take a course. He's taking college algebra. Now, let's have him take another course. He's taking Java 1. Now, can we leave just Java 1 out there without a name? No, we can't. Okay, because if we just looked up Java 1, there's no name attached to it. So we need to fill in the appropriate information that goes with it. Okay, so we have to fill in all the appropriate information that goes with John Smith taking Java 1. Okay, let's have him take another course. We'll have him take Comp 1. Once again, we have to fill in the appropriate information that goes with it. Okay, so you sort of see here, if we add courses, we have to fill in the corresponding information. So let's go ahead and have him take a few more courses here. So we'll have him take history, American art, and jazz appreciation. Okay, so if we did a search on that, we have to attach John Smith to that data. Okay, now let's go ahead and add, we'll just add another student here. We're going to add Sally and John. Okay, because this is typically what we might collect on students on there. Now I want to point out a couple things here. First off, do you see what's going on with this database? Did anything stand out? Let's look at this right here. Look here, we've got some repetition going on. Let's look here with Sally. We have more repetition going on. Okay, so what does this mean? There's two things that's happening here when we see this repetition. First off, all this extra repetition is taking up space on a hard drive. Okay, can you imagine if we had thousands, tens of thousands of students? Okay, with all this repetition on that, that's taking up a lot of extra space. The other part of this is, suppose what happens when John Smith moves. Okay, that means usually somebody has to come in and retype all this information to his new address. So if we've got lots of repetition on here and we have to do a lot of changing with that data, there's a possibility that we can make a mistake on here. So our accuracy on changing that data can possibly go up. And we want our data to always be as accurate as possible. We want to keep that data integrity right there. So we need to work at some ways on how we can eliminate the redundancy to save space and to keep our data accurate. Okay, so there's a couple ways of doing that. First off, let's go ahead and split the table. So we'll split it right there. And we're going to add some student numbers, some student IDs. As we can see here, Sally has hers already filled in. So let's go ahead and fill in John's. Okay. Now we've got these two tables now. And just to reinforce the fact, let's make them stand out a little bit. So now we have these two tables in our database. We've split them out in two separate tables. And look here, we have these student IDs. Now student IDs uniquely identify a student, right? So 444 uniquely identifies John Smith. Okay, so 444 is a unique identifier. A unique identifier in a database is called a primary key. If we use that primary key in another table, we then call that a foreign key. Okay, so we need the process here of connecting the two tables. So what we'll actually do is we'll actually connect and make a connection. We'll make a relationship between the two tables. So this connector right here is what they call a relation. Okay, so let's think about this. We know 444 uniquely identifies John Smith. 555 uniquely identifies Sally. Okay. So what does that mean? That means we can take this guy right here and we can actually get rid of those. Right here, we can actually get rid of these guys as well. So that we know that this Sally is connected to 555 and John is connected to 444. Okay, we get rid of our redundancy. We only have one line of data to correct if we need to or change. That keeps our data accuracy up. And that's starting to make our table very, very efficient. Let's talk about a few other things. A row in a database is called a record. A column in a table is called a field. Okay, so when we talk about records, we're talking about a whole row in a table in a database. And when we talk about individual columns, we're talking about fields. They are called fields in a database. So this whole process that we've done is actually called normalization. We've normalized the tables on that. Now we'll actually get into a little more on keys and a few more aspects on normalization. But the big indicator that tells you what you might have to do to normalize a table is you look for repetition. Remember, we had all this extra data right there. Okay, so that's a clue that, hey, maybe we should break this out because that was tied to our courses. So if you start to see repetition, then we look for ways of normalizing those tables. So that's a basic step through on how we normalize tables. Okay, a unique field that identifies that particular record. Okay, so this unique field 444, which uniquely identifies John Smith. Okay, the 444 in this table. Okay, this table right here is a primary key. Over here, the 444 is a foreign key. So this is a foreign key. And on this table here, it is a primary key. So that's the basics on creating tables in a database. We'll further go on and we'll talk about the different types of how we can connect these. So that's the very basics on creating tables in a database.